reconnecting. What happened? Oh, did the just break off? Did we have an issue here? Did the stream break off? Is it back on? That's the question now. It's alive. It's back. Did it disconnect? I'm not sure how much was left out. Oh. How long was I gone? That's annoying. I'm sorry about that. What did I do? Nothing. I didn't do anything. Oh, okay. So for 47 microfarad got resolved a while ago. Anyways, I don't know how much, because somehow my internet disconnected, I guess. And now it is back. Last pin. Last pin. Yeah, I don't know. Okay. So I was talking at some point about Tim's Tomu Plus designs, and we were looking at them before, and we were curious. Okay, so I was pulled out the LED and then it's disconnected. Okay, so I was after I pulled out the LED, what I did over here is I wanted to show you the awesome insides of the PCB of the chip. So if you look here, it's pretty impressive. So you see the bond wire connecting to the die, and the die then is sitting on this pad that is then connected to ground. So I was also mentioning that I think today I retweeted someone's post that they were showing a bonding machine connect pads on a silicon that they design. I think it's their ASIC, and it's really cool stuff. And it's quite nostalgic to me because one of my first jobs was at a company that was running running machines bonding machines. They were using aluminium, not gold wire, but still it was very impressive. And they were using it mostly for bonding to PCBs, just like in that video. So that's pretty cool stuff. Yeah, so the interesting thing was that these machines that they were using were actually really, really old machines made here in the US. And they were not getting newer machines because the ones they used were very easy to modify and improve and adjust. The fun thing was the whole vision section that was used for alignment and finding fiducials on the boards was all wire-wrapped logic. It was not implemented in any discrete. Basically, it was built out of logic gates. It was a full side panel of the machine. If you opened it up, you saw all the wire wrapping inside. It's really cool stuff. But yeah, they didn't want to get newer machines because first of all, they're very expensive, and second of all, they are not as well documented. You cannot work on them and modify them and tweak them to the degree they can. So they were getting quite a lot of contracts for designs that were tighter than people that had the state-of-the-art, newest bonding machines, because you couldn't tweak them and drive them beyond what they were designed for. Yeah, that would be. So Anand's idea is to use a BGA and bond wire it out. Take the silicon. You can buy some chips. You can buy even from DigiKey as just pure silicon die, and just bond that. That would be really cool if someone did it on YouTube or something and showed it to people. It would be really amazing. What did I have in here that I lost? What was that supposed to be? That's the chip. So this is a microcontroller. I can put the second one in and put it away. Now, 4.7 micro. I think the first one from the bottom, these are the 215 ohm resistors. Yep. Yes, I think so. All right. So 215 ohm. Let's look for them. 15 ohm resistors. Doing things the wrong way around. Yeah, sure, why not? Take a BGA, flip it upside down, and do a dead bug using bond wires. Sure, that sounds like fun. Ohm resistors. One. Very blobby. Solder paste here. Oh man, it's a mess. It's too much. Yeah. I want my stencil. Give me a stencil. All right. And 2. Yeah. Someone was asking me the other day about OSH stencils, if you can publish a project the same way as you can do with OSHpark. And I was looking, and I don't think you can. That would be really useful to have. OSH Stencil was announcing that they're releasing some new features in like the next few days. Yeah, Killeth, yeah, that's correct. There is no tag for 0.3. And yeah, let me go back. Oh, stencils from OSH Stencil. And I hope that the new release that they are planning to do today, tomorrow, something like that, will include project pages so that you can release stencils and make a link to a stencil and release that with your design. So 1 micro is the second one. So 1 micro, and then the 4U7 is in the middle. Okay. We need 2 of these, 1 and 2. There we go. Is that visible? No. Yep. One. Wow. And 2. Yeah, you should poke Zobs. Okay, and 4.7 microfarad. Yeah. There we go. Let's put that on. Yeah, this will probably need some more soda paste. It's like there was too little, now it's too much. No, now it's too little, there was too much. Okay, let's poke it. Come on. There we go. Yeah, it's good enough, I hope. All right, now let's put the microcontroller on. And the pad was like this. We can also compare it to an assembled one, because we have that advantage of having fully assembled ones. Yep, so the dot goes here. And Shook. Come on. Release. Shook. There we go. Very nice. Okay, so now let's fire up the rework station. It's like, let's get it completely in view like this, nicely focusing. Like, I think there's, let's do this. Can we have it so that it is somewhat focused and not completely out of focus? All right, let's try it. All right, so okay. Now, let's heat it up slowly and see if we can reflow that board and get something that works. Yeah, I'm slowly heating it up. It will take probably a while, because normally the curve takes, what, 7 minutes? I don't even have a timer. Oh wow, that went fast. There we go. Sorry, I'm trying to concentrate. Yeah, that looks good. All right. Did that work? Now I have a short here, right? It's just large. It's just too much. Yep. Okay. It's a little bit messy, but overall seems about good. Yeah, I don't know. Is it good enough? We can also add some flux around the chip. And heat it up again. Wow. Yeah, I hope that will be good enough. I am not happy with this edge here. It's heating up. You can switch this guy off for now. Yeah, should be good enough, I hope. So now, let's see, can we clean it? We will need to make the adapter for BMP. That will be the next job. Okay, let's clean this. Get this, let's get some flux remover, and let's get a toothbrush. Come on. That's not what I meant to do. All right. There we go. Come on. Okay, that's better. It's still filthy. Yep, that has to be good enough. Yeah, the pads are underneath, so they are actually disconnected, which is interesting. The lead frame, that's how it is called, the metal part inside a plastic package, it's the lead frame. And the lead frame on QFN packages sometimes has a connection between this stuff that hangs out on the side. This is like, so they come in this lead frame, like a panel basically, the copper parts that are used to connect the die to the outside world. And when they mold over them while they are still in that lead frame and then cut it off. So on the sides of the chips, let me show you on the EFM chip here, and naked one. The side copper, yeah, I will put it back in a second, but yeah. So if you look at this, you see it has the lead frame that is protruding out the bottom of the thing. Let me just put it on the table like this. And if you look at that, Oh, these are test pin pricks. I'm pretty sure this is like a test pad too. But yeah, so you have these connections. But if you look at the side of the chip, let me try to stand it up right. There is the copper hanging out on the side. And this is where it is being cut off from the lead frame. But the edge itself, damn, it is dark. It's really difficult to see, but the edge itself is plastic. The pad on the bottom is physically detached from the side, but if you solder it to the board, you can get the yeah, the edge is not physically connected, but it's like if I solder it on here on the board, like some of the pads I have connection between the side, the metal part, and sometimes I don't. But I was confused a little bit if I shouldn't have it connected everywhere. Damn, it is dark. If you lay it down on the board, it's like, am I doing something wrong here? Yeah, it's now it became very dark. Let's crank up the contrast here. Where's the camera? There's a special mouse for the camera here. Yeah, there we go. Let's crank up the exposure here. Yeah, so it's not perfect here. Some connections between the copper on the side and the pad. I don't think this is a big deal. It should all work as long as the underneath is connected and the corner is not connected. There shouldn't be a pad on the side, but the lead frame has connections there. Yeah. Anyways, yeah, this should be connected, hopefully. Well, we will see in a bit when I get the programmer attached to it. Yay, now it is totally overexposed. Yeah. There we go. Yeah. All right. Let's close this. Move the mouse and hide it. Come on. There we go. Okay, so let me put away the chip. Oh. Okay, so now we need to take the 7-pin adapter, I think, for the Blackmagic probe and try to flash this guy. Which board do I take? I'm curious also because this has 5 volts as a supply here, if it will run on the 3.3 volts that the Blackmagic probe can supply. Yeah, so this is my 7-pin pogo pin. So that's a 7-pin pogo pin for the Blackmagic probe. But this has more pins. So what do we have here? We have VCC, TCK, ground, TMS. So the order here is not correct. I won't be able to use that because this would be nice if I could just do that like this and just program this guy. That would be great. But yeah, I would have to make some adapter cable for this. Let me think. So yeah, we have this pin header. We can take the pin header and connect it here. And then there's Then we need, yeah, I have one that is like this. I will break it off. And now we need some jumper cables. Yes, I have a board like this. Let's see. So we need VCC. We need VCC. We need 4 pins. So VCC. This one has 5. Then we need TMS and TDI. No, TCK and TMS. TCK and TMS, and then we need ground. Yep. I think, because I have a, yeah. So yeah, let's see. VCC, TCK, TMS. Because that would be VCC, SV clock, SW clock, and SWDIO. And we have ground, clock, data, 5 volts. Like this. Let's do that. So we need power, clock, ground, data. Very nice. So green would be yeah, so I got the one of the 7-pin adapters. I added a pin header, so this is a Blackmagic Probe 7-pin adapter. I really hope this this actual EFM chip is already supported in Blackmagic Probe, otherwise I'm slightly screwed. Because I will not be pulling out a Raspberry Pi and figuring out OpenOCD. It's way too much trouble. I rather add support in Blackmagic Probe if I have to spend time on this. Okay, green. Green would be VCC. And now let's do this. So we need VCC, that would be the last pin. Then we have data. Data is gray cable. Then we have clock, and that is blue cable. And then we have ground, and that should be the like pinkish cable. All right, that's my wonderful adapter mess. So we need a USB cable. Okay, now I'm curious. Okay, let me put away some of the stuff here. I will need that bootloader So maybe we should look into that first to get the bootloader. Or we just connect to the Blackmagic to the chip first and see if it is actually enumerating. So this is hardware. Let's see. Okay, so we want the DFU bootloader now, right? So we should look Tomu bootloader. Kitlith, that's awesome. Thank you, Kitlith, for the pull requests. That is awesome. I'm glad you're doing this. We all will appreciate that for sure. Oh, this is... Just make a pull request and dump it on others. Perfect. That's how open source works. Like someone is like, oh, I'm done with this. Here, take it. Have fun. Oh, that's great. I love that. Okay, so I have this page here. Is this and let me see. And there we go. So that's the page. So I'm here on the bootloader page. Let me try to compile it. Wrong. I need the git key. So git clone. No. What? Come on. Yep. Tomu bootloader git. Now, Tomu bootloader git. Let's see. What do we have in here? How do I compile this? Is there some special approach to it? No, I don't want to be on Zob's user page. Using, there is a domain application. Boop, boop, boop. Programming API, building, to boot, make. Chink, compiled. Okay. Yeah, thank you, Tom. Have fun. Yeah, it's already 6. Gee, it's many hours of streaming. But yeah, we're getting there. We're getting there. So ARM noniabi GDB, and then to boot elf. Tar ext. So yeah, this should be div tty acm1. No? Dmessage. Oh, it is 0. Interesting. Okay, so because this is disconnected. Fine. Connection closed. Why? What? This might have some weird firmware on it. That's totally possible. Yeah, this has some weird firmware. Yeah, it's the debug firmware, I think, on it. So that's why. Where is my good one? C. 1 bit C, 1 bit C, black magic probe, more black magic probe, more, but I want the good one. Huh. I'm confused. What about this one? Is that a good one? Let's try it. This is version 2.1a. That's old. I'm a little bit confused. I think I thought I had a black one. There we go. Let's see. Yep. Okay. It was trying to do stuff, I think. Not exactly sure why connection closed. I don't know what's going on here. Let's disconnect this and connect this. I'm a little bit confused what's going on here. ACM failed to set DTR RTS. Connection closed. I'm really confused what's going on here. I have not seen them do weird stuff like that before. It should just work. Tilde .gdb init. What do I have in here? One version, yeah. I'm really confused. That's the bootloader. That's the firmware. Connection closed. Error in source file. Line 10. What is on line 10? Tar X'd? It can't do that? What? That's... yeah, connection closed. What? Why? Which version of GDB is this? This is 7. holy crap, did something break here? I'm really confused. Okay. Let's try this. Okay. Let's go back in time here. We might just have too many like high-speed USB devices on the board or something. And it's just having a lot of trouble with it. Connection closed. That's very interesting. What do I have connected? Oh, that's the camera connected back in there. Yeah, I have just those options. So yeah. It's really failing. Connection closed. Weird. Yeah. Rounding interval to probable, yeah, serial number, and then endpoint. Yeah, it's having USB issues. That's interesting. No, actually, I think there's, because I have all those cameras connected over USB to my laptop, it's completely going haywire. And I can't connect to it. That's so weird. I have not seen that before. Yeah, anyways, I think we will have to actually wrap it up as it is at the moment. And I will have to figure out why I can't get the programmer to just connect to my computer. I think this is related to the to having so many USB devices connected at the moment. That's the most likely reason, and USB is unfortunately quite an annoying piece of technology sometimes. But I have not seen that before. But I also didn't try to do GDB and Blackmagic Probe with having all those video streams running at the same time, and then so I should probably in the future have a dedicated streaming machine that is doing all the streaming, and I just HDMI capture everything to the boards. We still had a lot of fun, I think, assembling this. I will pursue finishing up this board and putting it together. It definitely is possible. It wasn't very complicated, even with the me just winging it and putting it on some solder paste, and now I have everything on my bag. So yeah, what should I say? I think the Tomu is really awesome. I really like that board. I think it is opening a lot of interesting opportunities, and I think if you have the time and you can just order some parts, you should. Also, you should go on the crowd supply page and back their project. I think they are doing a great job. It's definitely one of those crowd funding campaigns that I can endorse. I know that Tim is creating really awesome hardware, and it's all open source. He really believes in this stuff, just like I do. I think that's awesome. Zobs is, as you might know, is also one of the Kozenagi company people that was found. He, like, together with Bunny and whatnot, was created. It's an awesome company that is into open hardware and open software. I think it is worth supporting this effort. I'm really thankful to Tim for sending me the hardware so we could look at this. We could explore things and like have a lot of fun here. also complain about missing documentation, as it usually is. It's like, especially, it's always useful to have another person look into a design and try to assemble it, because then you find what is missing. I don't think it actually was missing anything. That's actually not true. We had all the information we needed to put it together. It's just I have other like things that I'm used to, that I do with my own designs, and I don't very often put together stuff that is designed by others. And I hope that we will do that more often here on the streams. I will probably try to make an edited down, like cut out all the FUD out of the stream and put it together in a shorter video that it is possible to put it together. If you think that's useful. Single chip jewel thief. Yeah, so Nexus is proposing to create a single chip jewel. Yeah, I don't know. I think we have a huge amount of projects already. So for the future, just to give a view of what will happen on the streams. While I was in Europe, I had the opportunity to talk to Tim, who introduced me to the people from Axiom Beta, or the open source cinema camera people. They were very generous of giving me a lot of the bigger parts on the PCB. So we will eventually assemble an open source camera on the stream, so get ready for that. That will be a lot of fun. Then I have a bunch of projects that are of my own that I'm working on. So one thing you already saw, that's the Icebreaker Board. This is based on Clifford Wolf's requirements. They will be making workshops teaching people how to do hardware design and do formal verification using open source tools. This is really like the cutting edge of awesomeness here. I'm really excited about this, because we're all used to unit testing and having automated testing and doing all this stuff in software, but it's not being done as often as one might expect for hardware. So Clifford and several others have started to build a full toolchain and documentation of how to do it, and are trying to spread the word and teach companies that are creating hardware how to do formal verification with tools that there is no excuse, oh, this is so expensive, we can do it. It's not expensive. It's there. It can be used. And do it, because that's why we are getting 100-page erratas, or we just find bugs in hardware after the fact and are like, well, deal with it. There is a workaround for it, maybe. So yeah, that will be very exciting. Kitlith, there is a workshop, not directly by Clifford, but by the group around it in the Bay Area. I think next month. You should check out, I think I retweeted it on my Twitter. I'm not exactly sure about the date. So there will be a workshop there. It will be the one and only just free workshop that they will be doing, as far as I understand. So get your hands on that one. Well, in silicon, adding bodge wires is sometimes difficult. So yeah, better do proper formal verification of your designs, which translates to basically assuring that things are doing what you actually expect them to do. So that's why you definitely should check out Clifford's talk from the Congress about formal verification of RISC-V ISA. So RISC Formal, I think that's called the project. The interesting thing about that is the fact that people are convinced that you can't do formal verification for anything complicated enough to be useful, which Clifford is pretty much proving is incorrect, because he's doing a full verification of an ISA, which is useful, and it's actually quite a big chunk, and he can do that. So if it is possible to build assurances for a complete ISA and the hardware implementation of an ISA, it is possible. So this is really exciting stuff to me, and I think this will be a game changer in the hardware industry, building actual ASICs and building hardware. So you definitely should check it out. And yeah, Kitlith is saying, yeah, it is in Bay Area. So you definitely should check it out. Anyways, on these streams, we will be doing more hardware, more assembly, more design. So there is the Icebreaker, the big one. I'm also making a smaller one that is inspired by the really awesome Tiny FPGA. This is also coming actually to Crowd Supply. There will be a campaign on there, and the guy behind it is really an awesome person. He is excited that we can work together on the bootloader he designed. So the difference between the Icebreaker and the Tiny FPGA is this one has a FTDI chip on it. I would like to not have the FTDI chip on it, but if we want to be transparently supporting IceStorm or IceProg, as well as the proprietary software from Lattice, they all just expect an FTDI chip that is wired in a specific way. Nonetheless, I wanted to make a smaller version of this, so I made something that is pretty much the format of the 1BitC that you might already know. And it also has the 5K LUT FPGA and ICE40 up, so Ultra Plus. The Tiny FPGA is using a different Lattice FPGA. It's a ICE LP, I think, with 8K LUTs, so it has more LUTs as far as I understand. But the difference between those two chains of FPGAs is the Ultra Plus has DSP blocks and some other like hard IP already built in. Oh, it can drive like RGB LED, so it has MOSFETs in it and stuff. So they're still very different. Yeah, the stream is still up. Hey Hedge, nice to see you again. I'm slowly wrapping it up. I'm just giving an outlook of what will happen in the future. I hope to make the streams more often than I did so far. Yeah, so check out the Tiny FPGA. So look for that. This is really cool stuff. Yeah, I got one. I want to play with it, and the USB bootloader on this gets rid of the FTDI chip, which is awesome. We will definitely look into that further and do some software development. I don't think this is something for the streams really, but this is something we will do to make the products from 1BitSquared more appealing and better. And collaborating with other open source projects is really top priority here. What else? We will be working, of course, on the projects that we already started. For example, the logic analyzer for cgrok, the FX2 Grok Tiny, that needs a different name, like really, I did it. I assembled a bunch. I gave a bunch to Uwe from cgrok and Lurchi and some others, and Abraxa, who are awesome guys working on the cgrok project, and we had really a blast at CCC debugging the FX2 firmware, LA firmware. So there was some like communication bug, and Lurchi committed a fix for it, which seems to be really fixing the issues. Oh, of course, Kate Temkin, thank you so much for joining the fight there too. It was really invaluable to help help with that issue. I think we have it mostly resolved. It still needs to be tested, so we will look into that. So anyways, the logic analyzer, oh, that's Seagrok Pebble. That's not a bad name. I like that. Anyways, we have to make a new revision of the board because I want to make one with more pins. Also, what we did at CCC, we reverse engineered one of the logic analyzer cables that Uwe had with him. That was really a lot of fun too. Yeah, I probably should get one of those logic analyzers to dig into that with better tools than I had at the conference. But we will be pretty much copying that design because I think it is pretty good. It has matching on the probe end so that the signal integrity is better. So it is a cable that has PCBs inside of it, which is pretty cool. So we will be probably building some prototypes of those. Then we have the BitLogic or BitMagic. Yeah, BitLogic, BitMagic, BitMagic. It's the high-speed logic analyzer and trace tool that we were working on. We will work on that too. So yeah, so far that would be it. I hope you liked the stream, and I will probably post on Twitter if I get the firmware loaded on this. I don't think this will be a big deal. I just have too many USB devices on my laptop, and yeah. One more thing. So YouTube seems to be deciding to stop allowing me to monetize my channel because I don't have enough subscribers or views. So even though I don't like doing it, it's like please subscribe and watch my streams. Maybe I will be able to monetize the channel again because by the 20th of February, all my monetization will go away. So probably I will have to look into stuff like Patreon or something like that. Or if you want to support my channel, please just get some hardware from 1BitSquared from my store. That is always very useful. This is what is supporting this channel and what I'm doing here. So yeah. Anyways, thank you so much, all of the people that joined the stream. Please support the awesome open source crowdfunding campaigns that are out there. And thank you for watching. And so, as per usual, if you have been, thank you for watching. And good night.